In this section, we'll go through several small exercises with multiple area OSPF. In this particular exercise, we'll cover the basics and add to that in the next ones. First, a reminder of what are OSPF areas. The main benefit of this concept is scalability. Using OSPF areas lets you scale up your network quickly and efficiently. So far, we did one OSPF exercise and we used only one area, and it's perfectly fine to do that, but now let's see how to configure your routers when you have multiple areas in your network. That is very simple as well. Let's say we have these three areas, area 0, area 1, and area 2. A small comment here, it is recommended to have your areas organized like this, meaning area 0 as the backbone area and all other areas connect directly to that area. But it can be configured differently. I'll show you this as well in one of the following exercises. Okay, we have these three areas and three networks inside them. We also have these two area border routers. So this is the first one and this is the second one. When configuring area border routers, obviously you'll have two or more areas to configure. You configure those areas by simply attaching the appropriate area number. This router is between areas 0 and 1. In area 0, there's network A. I simplified this if it's not obvious. So what we'll configure here is advertise network A in area 0 and advertise network B in area 1. On this router, we'll advertise network A in area 0 and network C in area 2. So you don't need to create these areas. You just mark which network belongs in which area, and that's it. Just in case you were wondering what to do with other routers, on those routers that are not area border routers, such as this one, for example, and those routers find themselves within an area, you'll advertise the networks directly connected to that router plus the area in which that router is located. That's it. Let's go into our exercise. This is what our exercise looks like. All IPs, all VLANs down here, all that is configured except for OSPF stuff. Let's start with router LAN. I'm going to go to Enable, Configure Terminal, and then get into OSPF right away. So router OSPF 1. And right away, we need to start advertising the networks directly connected to this router. We have 192.168.0.0, so I'm going to say network. 192.168.0.0, and then a wildcard mask 0.0.0.255, and then area 1. So this network is inside area 1, and that's exactly what we will configure. Next, we want to advertise this network right here. So it's network 11.0.0.0.0.0.3, and then area 0, because this network is inside area 0. Area 0 is marked right here, not very visible, but there it is. Okay, I'm going to exit the router configuration mode and move on to router 1. Of course, there is an exercise guide for you, but no need to look at that. Go into OSPF, router OSPF 1. Network 11.0.0.0.0.0.0.3, area 0. So this router is not an area border router. Therefore, all of the networks that we advertise will belong to area 0. So I'm going to hit enter on that upper arrow, switch that into 12 and then 13. And now I should get some information. Here it is, that neighborship has been established between router LAN and router 1. Let's exit the router configuration mode and move on to router 2, for example. Now on router 2, we have 2 VLANs. Let me check how is that configured. Is it a router on a stick or something else? So show run. And I'm hitting space to see more commands. So we have 12002, that's this interface right here. We have the serial interface, that's 14001, and then we have these 2 sub-interfaces for the 2 VLANs, and this is very obviously the router on a stick configuration. So what we will do in this case is we're going to go to configure terminal, router OSPF 1. We're going to say network. Let's list the VLAN networks first. So it's going to be 40.0.0.0.0.255, area 0, and then the same for network 50. Next, we will advertise these 2 networks. So network 12.0.0.0.0.0.3, area 0, and then change that into 14. And then we should also get those informational logs saying that neighborship has been established between router 2 and router 1. Moving on to router web. Router web is an area border router. So here we will have both area 0 networks and area 2 networks, right? So this is area 2. Enable configure terminal, router OSPF, network. Let's start with area 0. Of course, it's going to be 13.0.0.0.0.0.3, area 0. And then also 14. And let's wait for these logs to pop up. Here they are. Now we want to advertise network 15.0.0.0.0.0.255. This time it's /24. And this one belongs to area 2. So that's what we're going to configure here. And that's pretty much it for router web. Let's move on to router named data, as in data center router. I guess that's what I was thinking when I created this exercise. Enable configure terminal, router OSPF, network, and then we have 15.0.0.0.0.0.255, area 2, and then we have 192.168.100.0.0.0.255, area 2. For some reason, the connection isn't being established. Let's check what happened here. There it is. For some reason, it was very, very late. You might notice something interesting here. Router web says that it has established a connection with neighbor 192.168.101 on fast Ethernet 0/0. So we know this is okay because the link is correct. And what's important is that neighborship is established. But why this IP address? Well, OSPF identifies routers using so-called router IDs. And the rule for picking a router ID is to find the highest IP address configured on that router on any interface. So this router data has two interfaces and two IP addresses, and that's 192.168.100 and probably 1 here. Okay, that's exactly what it is. And then 15.0.0.2 on this interface. 192.168.100 is a number which is higher than 15.0.0.0, so that's the IP address that's going to win and become the router ID. There are ways to change this, but that's too nitty-gritty for this exercise and for this course, so we will just skip that. If anyone is interested in that particular configuration, I might create an additional exercise on that, so let me know. Okay, we now want to test if everything is working, and what better way to do that than to do a do show IP route command to check if we can see all of the routes or all of the networks that exist in this exercise right here. It appears to be so. We have all the networks 11, 12, 13, 14, 15, 40, 50, 192.168.0 and 192.168.100. You will see these interesting labels here. So networks 15 and 192.168.100 are directly connected, but these other routes, our router data, learned from other routers, and not only other routers and OSPF, but also from distant or remote areas. So you can see here that IA stands for OSPF inter area. So we learned about these networks, or these networks are not in the same area in which this router is located. Let's try some pings. Let's try this one, for example. They're all successful. All right, see you in the next exercise.